to Advent of Code in Liquid Haskell. Today will be day 23. I wonder, it appears like yesterday I didn't plug my headset in. I don't know how long that has been the case. I'll try to do better today. Oh, look, Windows is updating. All right. So I'm missing 3 stars so far. One of them was last night's puzzle. I didn't get the cube all set up, but I have my paper foldable cube all set up with the coordinates marked with which edge to fold. So I just need to find a way to implement that that's not too painful. I was trying to write a function that I could just chain together, listing all the coordinates of the edges. But I didn't get to the hard part yet. um, so I don't know if that's a mistake or if that's a good way to approach it. So let's get ready for day 23. So I got some answers about things that puzzled me from the Liquid Haskell Slack. So one of the things I was puzzled about is like why wasn't null working? The answer is because it picked the wrong null. So if prelude null is different than the one with refinement, I should have used GHC list null. I got some more advice on the measure I was trying to do to simplify to prove the correctness of the code where we were doing the expression reduction. So thanks to the folks at the Liquid Haskell Slack who've been very, very helpful and responsive. I try to report bugs as best I can, but it's never quite clear, is it a bug or is it that I don't know what I'm doing? I know what I'm doing a little more yet. But all right, let's put that away. And we're ready to go. Okay, elves and empty ground. Outsiders gain more empty ground, extends a long way in every direction. Looks like we're implementing a CA, cellular automaton, I guess, properly. Yikes. Okay, so the rule changes each round. first direction else considered is moved to the end of the list of directions. So we rotate that around. All right. Count the number of empty ground tiles contained by the smallest rectangle that contains every elf. All right, so how big is our input? Fairly big. So we're going to use a map. We're going to, for the starting position though, okay, our tiles, our elves are empty. Let's import. So let's, so we're just going to read the input, scan the input every time there's an elf. We'll add a coordinate to our list. So do we need coordinates? We do. Let's grab. Nope. Should build an index. When was the last time we used a coordinate? Guess that's what grep is for. That's voxels, close. There we go. Okay, there's our handy coordinate type. I'll keep the ordering the same. All right, so we're going to given a set of strings, we're going to return a list of coordinates. Okay. Okay, so let's scan for elves. Elves? Are they elves or elves in the advent of code layer? The elves. All right. So we're going to start at 0. Yeah. So this is our y coordinate and our row something. So scan for else y. If we're empty, then it's just an empty list. Could we be using the list monad here? Got this extra y coordinate. All right, so we're going to use the list version that I hope exists of the vector function we used last time. So, oops. find indices. Okay, so we want to map x to coordinate y, x, y of find indices where the character. Oh, we can use the other version. We can use LM indices. Even better. Else are those indices. So that gets us the coordinates in the current row, and we're gonna I don't know which is more efficient. I guess neither is particularly efficient. To scan for elves y+1 on the rest. All right. It was reasonably painless. The constructor for chord is point. Great. All right. Okay, let's call map from coordinates to tiles. So the starting position given list strings is so we're going to map dot from list, and the list is maps coordinates to coordinate comma elf. Do we need a map? I guess we just need a set. All right. Let's do that. Since we only got either absent or present, so I hope we don't regret this. Great. All right. Um, so we've got 4 rules, and we're going to have to rotate them around. So let us actually expand this. What happens? What happens if no other elves are in one of those 8 positions? The elf does not do anything. Okay. All right. So a proposal is okay. Are we going to have to remember? We're going to have to remember for which elf what proposal they made. And I think the answer is no, we can skip that by just calculating it again. So we're going to do one phase in which we record all the proposals. And we're going to do a second phase in which we're going to do that again, and they move if no other elf made the same proposal. So I guess we need the map after all to count how many elves made a proposal. All right. So proposal is a function from the grove and a coordinate to, hey, this is where I'd like to go. So sure, let's try writing those, see if this can work out. Okay, if So we need to look north, northeast. There are no, all right. Okay. Set dot member elves of current state at status direction. Okay. X minus 1. And no elf G point. Oops. All right, so that's northwest. This is north. That's northeast. And that's where we want to move north. And these are all equivalent, yes. All right, so south is y plus 1. All right, could we create a higher level function? We could. But I'm not going to. Okay, that's west and east. All right, so to make a proposal, we need some So we first need to check if everything is empty before we go down the list of possible moves. All right. So if empty neighborhood, then we don't make any proposal. Else we're going to work our way down the list. The list should and stop at the first non nothing. First just. Is there a function to do this? We can build one. We can use maybe to list. Oh. We can use cat maybes and take one. No, that's not quite right. All right. Gonna map maybe given a proposal, call the proposal on the elf. I don't know if there's a clever way of doing that. Is it dollar? No. Hmm. All right. All right. So if Is this what I learned about today? No. Oh, proposal on the grove and the elf. All right. So the start position is the elves are parsed as before, and the proposals start with north, then south, then west, then east. All right. So all right. So we're going to move. All right. So single round on a grove is okay. So we're going to what does sets map look like? Yeah, it returns a set. So every elf makes their proposal, and we have them as a list. Um, we're going to filter that list for duplicates. In a way yet to be determined. Probably overcounting a map. All right, and so then we do. All right, so that is round one. That's the first half of the round. All right, so Now we need to return a next so our L's are going to be move L's given their given the duplicate set. Sure. And then the proposals equals tail proposals plus, so we rotate it to the end of the list. All right, so let's write those functions. And let's tell Liquid Haskell that the length of the proposals always has to be 4. Illegal. Illegal type for G. Oh. That's odd. That looks odd. Let's take a closer look. Oh, it can't get there because all the things we didn't define yet. So, go. Actual type maybe. Oh, I see. Okay. Yes. How do we? There we go. I wonder if it's that this type is a problem. I hope not, because we kind of need it. All right, if we take this back out, is it happier? Doesn't look like it. Well, this could be a real problem. Well, we could do proposals just in terms of the set of elves, I guess. All right. What if it is from? Yeah. Hmm. Okay. So we're gonna do set. Hello. How are you? Yeah, I rage quit part two as well. I have a paper cutout to help me if I want to finish it. I have it coordinates and which edges go with which, but It's a pain. So is Liquid Haskell right now. What the hell do you mean? I have two cutouts. I have two cutouts, one for each. Do we need to name it something different? All right, let's fix all these. Why are you being such a pill today? Yeah, yeah. Well, I had looked at mine first, fortunately, but I didn't even get to the point of getting the example working because it was requiring more 3D manipulation than I was capable of late at night. Is it that this is a function? Okay. G takes a main dot proposals, which is a function. Yeah, and it takes elves and it returns main.elves equals blah, main.proposals equals blah, and you'd say you don't know what that is. Well, I mean, in theory, you could write code to recognize what folding needs to be applied. I just don't know. I don't really have the know how to do that. I even read a book on folding algorithms. I don't know where it is on my shelves. But yeah, I don't think anybody was actually going to do that. Did do I need to call it something? What if I call it foobar? You gotta be shitting me. All right, there it is. Oh, sorry to hear that. Yeah, that's a tough one. Uh, I was considering just printing out a big copy and assembling the cube and doing and trying to do it by hand. But the set of instructions is kind of long for that. Yeah. Uh, uh, did I become stupid? All right. What if you are an int? Oh, my vacation started. All right. What if you are a list of ints? Okay. What if you are functions from integer to integer? Boom. All right. Oh, there's a flag I can try. Improving incremental. All right. It'd be nice if there was some hint about why we might need to use this. All right. So let's go back to okay. Now what we were doing before we went on this detour. All right. We were saying this has to be a list of length 4 so that we can rotate it. All right. Great. So filter duplicates, we're given a list of chords, and we're going to turn a set of chords. All right, so let's All right, let's go all out on functional programming here. We're going to treat each of them into a map, and we're going to. Oops, this is data set. No, so what I want to do is take two maps and specify how they get merged. So there's a union with the combining function. Yes, thank you. Okay. Okay, so let originals is we're gonna create singleton maps. Is that a thing? Yes. With count 1 over, yes. All right. And then we're going to um, so we're going to do map.union. We're going to fold union with over that set. So union with plus. So that's a function map to map to map, which we need over the originals. All right. So, and then we're going to return um, all right, so dupes, we're going to filter the map to those with count greater than 1. Filter all values. Yes. So count n greater than 1. Dupes dot and I need to stop pluralizing my type names. All right, so this should be um, nice if I could write a specification, but we use both map and set, so kind of out of luck. Maybe we should rewrite it to work in O of n squared time and prove it's correct. All right. Move L's, G, and the duplicate locations. Okay, so this is also a map. This is a map. No, this is a set map. So we're going to take the L's or G and we're going to do something to them. So we're going to call that move if not in duplicates. Okay. Duplicates. So we're going to run something's wrong here. This map. Oh, because he hadn't defined filter. Okay, we only want to take the ones that have proposed that they move somewhere and do our duplicates. But here we care about everybody. So case make proposal G position. So where does that elf want to move? If it's nothing, then he stays where he is. So if member new pause in duplicates, then stay where you are, else sure, you can move to your new position. Great. So is that everything we needed for a single round? Let's Liquid Haskell's being awfully quiet here. Oops, save it. Find but not used west. Oh, all right. We need to. We'll probably get some more complaints once we set this all up. So Okay, so we parse the input and set up the initial list of proposals. And then for part one, we're going to iterate. All right, states equals iterate single round on start. Okay, and so we want to take the first 11 steps. Okay, so this needs to we could build a little better show. How much are we gonna regret not having it? Oh, yeah, we have to write one because it can't print out functions. All right. So we have to calculate the bounding rectangle anyway. Uh, that is smallest rectangle that contains every elf. Okay. Yes. So the good news. No, we can't just take the min. So the min will give us the y coordinate. All right. We only need it once, so I'm not going to worry too much about efficiency here. We will say it's map x chord over minimum, maximum. Oops. No, that doesn't work. What? Okay. don't like that you have a parse error here. Oh, it just hadn't caught up. All right. Okay, so we're going to unlines of, we need our special split library to do chunks of. The chunks have size x max minus x min plus 1. And that we're going to apply that to okay. So char xy is dot if set dot member. Oh, we already got a function. If phooey. I rewrote it and I probably didn't have to. Char. So y goes from y min to y max, and x goes from x min to x max. All right. 7 minutes. Yikes. All right, and then we need the magic incantation to say in implements. I can never remember this keyword. Instance. Yes, this is an instance of the type class. Okay. All right, let's try this out on. We didn't copy the example yet. Where are input? 5 L's to start. Bigger example is this one. And our input is this lovely pattern. Okay. No elf. Got that backwards. Yikes. Well, this is another example for the liquid Haskell folks, I guess. So similar to the error I reported. What can we do? What can we do to simplify? Well, one of the things we probably need is to tell it about it. We'll use take. That's fine. Um, Gosh. Um, okay, so we could move our puzzle to a separate file. Let's try that. All right, let me. Let's preserve that for future generations. All right. It might be that we turned on higher order. All right. Package puzzle. And we're going to have to export a bunch of stuff, but I don't know what it is yet. Okay, so we're module. So we're going to have to output start position and single round. Is that it? Can we just leave the other types unexported? Oh, okay. We made that's right. We didn't use tiles after all. No, I don't want integer. I want int. I don't understand this last problem though. Okay, let's just delete that. Okay, if it doesn't like that. Don't know why it's changed. Changed when going from main to another package. Okay, can we switch this back to Grove? And then we'll have to fix these. That's very strange. Yeah. Okay. So okay. Change that back. We need to get it there too. Okay, maybe we need to. It's defined up there. What the heck? It's never where I expect to get stuck. All right, I guess I need to. All right. So, did I copy the flag wrong? No. Do I need to export them? Word. I figure it's worth a shot before I. I mean, these are all showing up when I'm compiling main. Um, oops, data. Was hoping to keep. Okay, great. It's incomprehensible, but we can work on it now that. Okay. All right. So what was I doing before? I was doing put Sterling of onlines map show Grove. All right. So, oops. So let's look at the small example. Okay, we parsed it correctly. That set looks good. That looks good. Okay, great. And they stay still. Great. All right. Let's do example 2. Yeah, yep. All right. So now we need to count the number of empty ground tiles, which we don't need to actually iterate to do. Hello, welcome. I am solving advent of code problems in Liquid Haskell, which adds refinement types to Haskell. Unfortunately, I haven't written very many refinement types today. All right, count. So we need the bounding box. Equals bounding rectangle. And then we need the number of L's equals. Good, you got it. Okay, so we take y min minus y max plus 1 times x min minus x max plus 1 minus the number of L's. Well, but did you get even? I think you can be mad and get even. Oh, great! I like Plants vs Zombies. Do I still have it? I do. Not installed on this computer. Congratulations. Yes. All right. All right. We're going to need our special magic about iterate. Our lie about iterate. Well, it's true. It's true. Dang it. I wish Liquid Haskell would put its iterate returns at least a million entries. All right. So we're going to print count empty of state 10. All right, let's try it out. Crud. back to this stupid problem. All right. Uh, all right. So we already refactored. So all this stuff was in puzzle. Okay. Can we disable high order, or will that just get us in more trouble? That gets the original problem. All right. Good night, wizards. No. Stay warm. Or is that a bad thing to wish a wizard made of snow? Stay frosty, I guess. What if we only do one thing? Maybe if we tiptoe around Liquid Haskell's problems here. This is very annoying. All right. So what? You put the IO stuff in a separate file. I'm kind of stymied as to how to get Liquid Haskell not to choke on this. Um, Maybe if we use only put Sterling. No. All right, we were fine like this, right? All right, what if we... Oh, you gotta be kidding me. All right, let's... All right. Okay, so we need to move this into the other file. All we need is to export that single function. And that should make it really easy. Hold on, of where? I guess the other thing we can do is refactor the other. Oops. We could refactor the other way. We could put all our I/O in a module and take it out of main. All right, finally. All right, is 68 the right number? Or are we gonna not even close? So it's probably I did get the move art. So there the state 10 is correct, right? They match up. So it's probably that I it's probably my logic here. X max yeah. I There we go. I did the subtraction backwards. Which turned out positive because they were both negative, but they were both off by 2. All right, let's try the real thing. Hey, all right. What is the number of first round where no elf moves? Yeah, I figured that was going to be it. Okay, good news. We already got an near infinite list. So we're going to zip it with itself. Okay. All right, we want the first round that nobody moved. So this compares each with the next, and that'll give us an off by 1 error. this compares state 0 with state 1. All right, we can make this work. So we want searching with a predicate. Don't want find, we want the index find indices. All right. So that's heavy quality, right? No, so we want elves of A is elves of B. All right, so this says 20 is the same as 21. So that means that 21 is the first round where no elf moves. So it needs to be x plus 1, not plus 11. Not some, just. All right, let's try that out. Can we get rid of higher order? Get rid of that. Oh, we need to export it. $20. Okay, let's try it on the real input. Should have timed it to see if it should have timed it to see if it's more less than 7 minutes. Um, yeah, that's about what I would expect. Um, we're not, because I used this set, we're not doing anything too silly, like iterating over the whole array, a whole array. All our, we are, so one of the things I considered early on was Do we actually record each intention and reuse those? And so I didn't, so we are rerunning the intention rather than memoizing it. So that's a factor 2 slowdown per round. The other thing I can think of is we could remember which elves are. Oh, oh, don't have to worry about it. That's the right answer. All right. Um, Great. How did we do tonight? Wow, sub 3,000 for both parts. Um, yeah. So, I mean, this is perfectly fine Haskell. It's not very liquid Haskell. I mean, it's often the case when we use efficient data structures like sets that don't have a model. So what? So liquid Haskell was definitely more pain than gain today. We could verify that all the proposals we could verify that all the proposals are either within one, but I mean within one. That's not really getting to the point of things. We could make this function a little higher level and pick a direction and only write it once. But yeah, I'm not sure what we could do to express this in the specification language. I just don't see a lot. Like, okay, so we'd like so here, we'd like to prove the correctness of this. This is very fancy. But I don't think like map union with has a specification we could use. But we'd certainly like to define that if something is in the set, then it is in the list at least twice. And that seems hard to express. All right, it's not too late. Let's work on our cubes. All right, so I was trying to write a function that would let me just express all the edges as parameters and the right thing would happen. And I'm not sure this is the right idea. So I'm gonna do it for doing it for all 16 pairs of directions seems like a lot. But let's see if I can write this version at least and see how horrible it is. All right, so we've got for north we've got a y coordinate like -1 if we're on the top, a range x start to n end to x end because there might be multiple edges, and we're going to map that to a different direction, a different y coordinate, or a different x coordinate. But if the new heading is south, then it's going to be y in a range of x's. So our new position is going to be y2 heading south, and it's x that's hard. So we want to be the same position between x start 2 and x end 2 as we were between x start and x end, but the direction may have flipped. So in the example problem, if we go off the top of A and come back down, then we have to swap coordinates. So if we're on the left hand side here, we're on the right hand side here, we're on the left hand side here. So this is going to be x start 2 plus y x chord of our position minus x start. Plus times the sine of so if we are at x start, then this is going to be 0. If we're at x start plus 1, this is going to be 1. And this is either going to be 1 if it's the same direction or -1. Okay. Can I test this interactively? I need to switch package back to day 22. I don't even know how we're going to prove what we're gonna, oh shoot, I didn't use chord, I used pause, because I'm an idiot. Yes, I used, yeah, I used X pause instead of X chord. All right. And then what is signum, is it? Signum. Signum. All right, I need to fix all these places where I used the wrong word. Okay. I should probably just break that up. Yes, direction is what I called the input. So these are orientation. All right, so this type is too big to fit on my screen. All right, let f equals transition edge north -1 from 8 to 11. That is going to go to south, and that is at y coordinate 4, and the reversed, so from 3 to 0. Wow. Right. So f of p 8 -1 heading north is 4, 3 heading south. And the mall confirms that's correct. All right, so what if we are at 10? Then we're at 1. All right. So, and if we don't match, then it returns the original. All right. So can we reduce this from 16 cases to a more manageable number? I don't really see how. But there are not 16 cases we actually have to worry about. So, all right, so we got north, north to south, uh, north, C, north to east. So there we switch coordinates. So same check, and otherwise and now we have to switch this around. Oops, this was, I did Y and then X. I should have caught that. Okay. So north to east, these goes to X2, and then these all switch around. Okay. And then north to west, we got one of those. So are those the same? They are. So if we had a type that was east, if we could put east or west in this pattern, uh, okay, we can. We can say such, we can put a guard, so neuter equals north or neuter, oops, east or west. Okay. So we can do the same thing here. Oops, but this had better be the new direction. Okay. And we should never, we might have to do it from north to north. No, we shouldn't, but it doesn't matter. All right, those are some very grody functions, but I think they do what they need. So let's reload that. Ah, yes, I screwed this up. Ah, good job. What did you fix? Ah, okay. Yeah, so there's an optimization possible, which with a lot of cellular automata engines do, is you can look at you can divide your regions into areas and say, this region hasn't changed, it won't change the next time, I don't need to check it again. Um, and that can be a big improvement if some of your state becomes predictable, so you don't need to do the full emulation. Uh, and that seems a challenge to get correct. That would might be interesting to try. All right. So what if this goes to east? Uh, so yeah, what if north at 3 from 4 to 7 goes east to 8 from 0 to 3. Yeah, I know. That's what I meant. Okay, so if we are at 4, 4, 3 north, then we're going 8, 0 east. If we're at 4, 7 north, then we're at, oops, if we are at 7, comma 3, then we're now at 8, comma 3. Yep. All right, checks out. So just have to do the other 4 directions. So south should be very similar. Is it in fact identical? So we're going to have a y and an x and y range, and we're either going to keep it the same or twist it. So I guess we could split that too. Don't feel very confident about that. I feel like I'm missing something. So if let's try it out. So if we're south between um, if we're at y equals 8 between 0 and 4, then we want to pop up north and row between 0 and 3. And we want to pop up north twisted Yeah, twist it around. So that's between 11 and 8. Uh, that's what reload is supposed to do. So it did recompile. And this should be covered. Okay. Maybe I didn't save it. There we go. Shouldn't be south though. That should be new deer. It should be, yeah. Okay. Okay. So those are identical. I don't really like expanding this to another clause though. All right, we'll leave it be. So we have to write west and east. Okay, so west we're going to have x and y start instead of, so x pos equals x, y pos greater than or equal to y start, y pos greater than yn, and facing equals west. And then this is going to be y pos minus y start. Okay. And do the same transformation here. That doesn't seem very big. I threw away my first attempt. My first attempt, I didn't center the cube on the page. I was using a Rubik's cube, and it went off the edge, and so I was trying to cram things in, and gave up on that. All right. Facing is west. All right. Well, after I finish writing this, I'll probably figure out how these can be collapsed. But I guess I have some confidence that west and east are the same. So if one is correct, the other should be too. Um, all right, so let's have a transition from west along at y equals 7 from 0 to 3. And that end up going south. And that's covariant rather than contravariant. So that's going to be south from x equals 4 from 4 to 7. So f of p 7 0 west is 4 4. Yep, those are the corners that line up. Great. So let's define the part 1 cube. So this is going to take a position and return a position. So this is if out of bounds, bring back into bounds. Okay. Okay. That is 0. That is y equals -1 from 0 to 3 goes south at 4 from no, that 8 from 11. This is going to be horrible. Blood everywhere. Okay, it's going to be y coordinate 4 from 0 to 3. All right, on P. And I'm using an either. And so each output, if it's a left, shortcuts. And if it's a left, it shortcuts. If it's right, it passes it on. I think. It's good. I might have to find my own operator, but I think that's the monad dealy bopper. All right, and the opposite of that is if we're at 3 between 0 and 3. No, it's backwards. This is a horrible idea. I wonder if I could print out. I wonder if I could print out a map that I could check. Okay. Okay, so if we're going north up to row 3 between 0 and 3, then we got to go south at y equals y between 8, 11, and 8. Okay. So if we're at x equals 12 between 0 and 3, then we go west at 11, at x equals 11 between 11 and 8. 8, no. Is this 11, 11? No. West. That is 15. 12, 15, yes. 15. Definitely my cheat sheet wasn't filled in enough. I'd only filled in the upper left-hand corners of each square. Okay, so yes, if we're at x equals 12 between 0 and 3, then that gets mapped. Well, it gets the sides flipped upside down, so that gets flipped between 11 and 8. So if we're going east between 16, between 8 and 11, I'm going to go west 11 between 3 and 0. So it feels like I could create something that matches these up. Remove one source of error. So that is x equals 7 between 0 and 3. And goes south at y equals 4 between, all right, that is not inverted. Between 4 and 7. So north at y equals 3 between 4 and 7. Becomes east at row 8 between 0 and 3. D, E, F, G. All right. Almost. I have 7 of them. All right. All right. This looks like B just shifted down. So between 4 and 7. And it goes south. At 8 between 15 and 12. So that's inverted. Between 7 and 4. Yep. Okay. Okay. I wish I could put this up to share. I could follow along, but it doesn't come through the camera very well, and I don't have a slide projector. um, all right, E. Where is E? Okay, E is off the left-hand side. So west off the border between 4 and 7 pops up north at y equals 11 between, all right, is it covariant or contravariant? It is contravariant. The bottom of one edge is the top of the next, so between 11, between 15 and 12. That's the same x coordinates as D, yes. Twelve between 12 and 15 becomes east at 0 between 7 and 4. There's F. F is south at 8 between 0 and 3. And it becomes north at 13 between no, it becomes north at 12. No, it becomes north at 11. 8, 9, 10, 11, yes. South becomes north, south becomes north. South at 12 between 8 and 11 becomes north at 7 between 4, between 3 and 0. Okay, one more. Such stunning TV. G south. All right, so it's part of the same border here. So between 4 and 7, but it goes to east at x coordinate y between 8 and 11. So west at 7 between, needs to be backwards. Yep. 7 between 8 and 11 becomes north at 8 between 7 and 4. All right. Let's try this out. Oh. Okay, we need to either change this type. So if we get all the way here, oh, this is not a maybe, it's an either. So if we were a left, okay, so it's going to be from left, and the default value is the original position. No, that's wrong. So what we want to do is we want to signal an error if none of these matched, right, to indicate that we have a problem. So um, okay, so x1 cube of p, all right, so if we're at x equals 2 and minus 1, heading north. That's not right. Oh, yeah, that is out of bounds. That is fine. If we're at 8 minus 1, great. What if we're at 3, 1, headed north? Oh, yep, that's bogus. I meant 3, 3 headed north. And yes, 80 headed south. Okay. So I would really, really like to print out a map of these. because I don't trust my own data entry. So the problem is each yeah. Okay, so the inputs and the outputs should not overlap. So what I can do, did I make a print statement? I did not. Well, that sucks. All right, let's do that. All right, here's what we're going to do. We're going to I don't know how I'm going to do this for part 2 yet, but for part 1, we can just print them all out. So I'm going to pick 26 at random. I don't know how to do that in Haskell. Does Haskell even have a random number generator? Do you have to use a state monad? I have to use IO. I would just do all of them, but I want to use the letters A through Z. And there's more. Oh, not that one. There's more than 26 things on the edge there. This is a lot of work. If only we were using a character set with many more characters. Yeah. I suppose I could do that. Right. I could devise a path on a empty input. Um. All right. Let's table that and adapt our code from part one so it works with this. All right. So move one step for part two is gonna have to is instead of using this wraparound, it's going to simply uh, move to an invalid, potentially invalid position. Oh, x then y, x, y minus 1 north. If I'd separate this out earlier, it wouldn't be such a problem. South. All right, so we want to either end up in bounds or fail right away. So we're going to add some additional check. Um, I think we're just going to have to tell Liquid Haskell to ignore the error that it will tell us could happen because we haven't proved that it cannot. And the fact that cannot is dependent on all this data. So yuck. All right. All right. So so we only want to call transition edge if we're on a blank or we're across the edge. So I guess we got to handle those separately. So if get tile is empty, I think I called it empty. Okay, so we need to make this a left. Okay. So if is right, then not walk, new position. I only have so many synonyms for new position. I guess we should do this as a case. Okay. All right, so we should check if Okay, so if there's a wall in the way, then after all that, we're stuck with our old position, else our new position. All right. Oop, I gave it the wrong name. It's very fussy about empty specifications. All right. So it's complaining that our errors can occur. Crud. So I specified that the positions are all greater than 0, and I violated that here. So all right, we'll relax it, but we'll say valid positions have that additional constraint. I don't mind a temporary out of bound position. Otherwise, we have to go rewrite everything to work with bare coordinate pairs. All right, so it doesn't like that we didn't handle all the cases. We can actually handle that fairly easily. We'll just put a catch-all. Blah, 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 blah. P equals y to P. All right, and we're gonna ignore it. Because they're not gonna be able to prove. Oh, for Pete's sake. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. All right. So now I think we just need to copy oh, this is silly. It's got an unnecessary parameter. All right. So now we just have to take our code to move. Okay, we got our new version of move one step. We're going to switch to move n steps and follow directions and just copy those. I mean, we could pass in the correct function for both to keep the existing definitions, but I wish that I could just say just the errors are unchecked in this function, because I really would like to make sure that we have a check that it's inbounds. So let's let's see if there's anything about this. Oh, there is a counterexamples flag. I should try it out. I'm not sure I'm running the right version. Okay, I know what we can do. So we can write an ignored error that takes a maze and a string and returns an inbounds M. which will of course fail because it says no such thing, but we'll ignore ignored error. All right, and then we can change these to ignored error, which we told liquid Haskell, ignore error M. We told liquid Haskell it returns the right type. We could even assume it. A encoding error. Maybe we do need an assume. Maybe we can't have our cake and eat it too. Maybe we could put this in a different package. Egg. So I want it to assume the type, but ignore the fact that whenever we call this function, all right, good, that worked. So it proved that if we don't call ignore error, then we actually did return something inbounds. Okay, so there's our move n steps. It calls move 1 step 2. We've got follow directions. Follow directions 2 everywhere. Let's move n steps. All right, and this returns a whole sequence of okay. So is that all we need? Looks like it. Okay, so we read our maze, we parse our directions, we call follow directions 2. So we can do if This is what I got an answer from. So the problem I ran into last time I was editing this file is that the null imported from Prelude Liquid Haskell doesn't think is the same null as the one it has a specification for. So that's what the funny import business was. All right, does that compile? They're gonna start complaining about things it previously didn't complain about. Okay, so we want example directions. All right, stack run. This is day 22. Please don't blow up. Please don't blow up. Oh, part one was still using the real instructions. All right. So let's look at okay. So 9-0 east 10. Get stuck there. For a while. 10-1 south, 10-2 south, 10-3 south, 10-4, 10-5. 11-5 east, 14. All right, so that's 11, 12, 13, 14. All right, made that transition. 14-9 south, 14-10 south. Okay, and heading west. 10-10. Stuck there a while. 10-11 south. 1,7. 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. Good. 6. Okay. 5, 3, 5, 4, 5, 5, 5, 6, 5. Yep, 6, 4. And then it gets blocked by the wall. Okay, so password is 5031. We got it right. All right, let's checkpoint this. So let's try to make things easier on ourselves. What time is it? 2:30 my time. I can probably do this. Let's figure out how to make these matched pairs. I almost just wish these were really an object so I could operate on them. Instead, they're just arguments to functions. There's no way we could pull them back out. Yeah, I don't think so. I think we're gonna do the real cube. Okay, the real cube coordinates are in groups of 50 rather than 4. Again, we've got same number of edges. That's probably the same for any unfolding of the cube. I'm not 100% sure on that though. Okay. So south at 200 between 0 and 49 ends up going south at 0 between 100 and 149. So if we go north at -1, and those, amazingly enough, are the number twists apart that they have the same order. Yep. Okay. North to 199 between 0 and 49. Okay. Where's B? Okay, B is difficult. B is east across 150 between 0 and 49. Okay. Uh, okay, east ends up going west at 99 between, it's almost easier to work with the 150s here. between 100 and 149. Nope, nope, it's turned around. Okay, so the opposite direction, we go east across 100 between 100 and 149. Then we end up going west at east across x equals 100 between y equals 100 to 149. Yes. West at 149 between 49 and 0. Okay, C is south to 50 to y equals 50 between 100 and 149. Oh, I drew A backwards. That's why. Yes, it matches up with the other side of A. Yeah. This and this are the same face. Okay, C goes south and pops out west. And it's covariant. So it pops out west at 99 between 50 and 99. So if we go east to 100 between that range, then we pop out north at 49 between 100 and 149. Okay. D edge. Where's D? D is north, so -1 between 50 and 99, and we pop out going east at y equals 0 between it's the number of twists that determine the covariance versus contravariance, but I have trouble believing it sometimes. So yes, 50 goes to 50 goes to 150. Yep, that's matched up with 050 0 is matched up with 150. So if we go west, connect 1 between 150 and 199, then we pop up going south at 0 between 50 and 99. Okay, home stretch here, E edge. So if we go west to we go west to 49. To x equals 49. Yep. Between 0 and 49. Then we pop out east at 0 between, well, it's reversed, so between 149 and 100. So I could write a constraint that these two always have to be in order and that the intervals are the same size. That might be a good thing to do. All right. Looking for any excuse to not finish this. All right, transition. So if we go west to -1 between 100 and 149, then we pop up east at 50 between 49 and 0. Okay. F. That's along the same extended edge. So if we go, that just adjoins. So then where is the other end? It is south at y equals 100. And it's between 49 and 0. Yeah, so 49 matches up with 49. So if we go north to 99 between 0 and 49, then we have to pop out east at 50 between 99 and 50. Okay, one more, G. So if we go east from east from 50 between 150 and 199, then we end up going north at y equals 149 between 50 and, oops, I think the F is backwards. Yeah, the F is backwards. Big further down equals further right. Yep. Okay. G, all right, where was I? X ranges from 50 to 99. So go south to 150 between 50 and 99. Then we go west, starting at 49 between 150 and 199. All right, let's try it out. So this is real cube. If we were doing this right, we'd encapsulate all the puzzle options in a structure and extract them from there, or something like that. Maybe there's something even fancier we could do, but I'm just substituting them in. Okay, so we're gonna do the real directions. All right. Moment of truth. Unless it doesn't compile. Let's try it out. That's the right answer. Amazing. Hurrah. I don't have to debug this. I can just be done. So, how many people did that? Still less than 8,000. All right. Well, thank you. There's a bunch of things we could do better here. I think it should be possible to, there's enough shared structure between the two versions of the edge that we should be able to write a single function that does both. If we just describe them in the right way, we could put some checking on here that, this has to be in order, has to be the same size as this. Sure, why not? So I don't care what that is. So So this has to be an integer that is greater than x1. All right, orientation. So oh, it's the absolute value. All right, I'm not gonna dig that up. We're just gonna say y2 minus y1 equals x2 minus x1, or y2 minus y1 equals x1 minus x2. I feel slightly better flipping it around. It doesn't make any mathematical difference. And then all right. So that should not cause any problem. If it does, then we got lucky and the bug didn't matter. All right. Good deal. All right, I'm going to check that in. Day. Oh, yes, I deleted some files. All right, there we go. All right, well, good night. Happy holidays. Thanks for hanging out. 3 stars in 4 hours, better than 1 star in 4 hours any day. Good night.